Hello there, MCTers. This video is a review video, and the goal here is to move quite quickly through some review examples, see some typical ones that you might see on the exam. Certainly a warning that this is not a complete list, that there's bits and pieces that will be on the exam that aren't covered on these videos, but it'll certainly give you a reminder of the main topics in each of the units. One thing that I'm going to mention is the note that you see here. You can print off the PDF. So the PDFs are, it's Unit 1, 2, and 3 review PDF, probably on the same page that you clicked on this link. So you can print these off and follow along, or not. I suppose that's up to you. I'm going to move through this really fast, so hopefully you get something from it. The way the videos will go is there'll be kind of a list of all the stuff we did in that unit, and then a few typical examples from that unit. So in Unit 1, we did all that special angle stuff, and then rotation angles from 0 to 360. This stuff all new. And then finding angles also had to do with the first two topics, and that was all new stuff. This is all new stuff for us, at least for the most part. The last one, when we were solving problems in triangles, was review of grade 10 and 11 trig stuff. So that stuff wasn't so bad. So let's get into it. Example 1, give the exact ratio for the cos of 210 degrees. So this is both a rotation angle, and it turns out that this is one of our special angles. So almost all these trig ones, what we do first is we draw a diagram. One of the things is to remember which quadrant an angle like 210 degrees is. So we remember we start on the positive x-axis, it rotates this way. That's 180 degrees, and then 30 degrees more, right? So, oops, kind of blew that. Let's go back a little bit. And then there's the rotation angle of 210 degrees. The big thing is the related acute angle is one of our special angles. And of course, we had that sort of chart that had all the special angles and the ratios. And with the related acute angle of 30 degrees, it meant we were in this spot in our chart. And I'm hoping that you have a copy of this chart on your formula sheet. That would be a great idea. And so we see that the cos of an angle with a related acute angle of 30 degrees is the square root of 3 over 2. Now that's not the final answer, because remember, the idea is that's the number part, but it could be positive or negative, right? And that's where the cast rule came in. If you remember the cast rule told us which of the trig ratios were positive in each of the quadrants. So all of them in the first, just the sine in the second, tan and cos. So in this quadrant, the quadrant where this 210 degree angle ends up, only the tangent was positive, and so the cos of 210 degrees is actually negative, and there's your final answer. It's just that easy. And so here, give the solutions for tan x equals negative 2.5 between 0 and 360. So, I mean, for most part, we might get something like that in grade 10 trig, where we got the tangent of an angle, or we want to find a side or something like this. Between 0 and 360, there's almost always two answers, right? If this is the XY plane, we think of the cast rule, and we're thinking, okay, where is the sine negative? Or where's the tangent, rather, because it's the tangent we're interested in. Where is that negative? Well, it's negative here and here, because the tangent is positive in the first and third quadrants, right? So it could be here. That could be one of our solutions, x. Call that x1 maybe. And our other solution is way down here. Call that x2. So, well, how do we get what those angles are? Well, it has to do with the related acute angle, right? We don't know what the related acute angle is. And when this was a special ratio, like square root of 3 over 2 or 1 over the square root of 2, we could do this exactly, but in this case, we're going to have to use our calculator. So I'm going to find the related acute angle, by doing the inverse tan of the positive one, right? Because if I don't put the positive one in there, it might give me all sorts of goofy answers. So I'm going to do the inverse tan of positive 2.5, and I get that that's about 68 degrees. So that means my related acute angle here, I'll get a different color, that this here is 68, right? So what's x1? And x1 is going to be 180 degrees minus the 68, right? 180 minus 68, which is, what is that? That's 112 about. And x2 is all the way around minus the 68 degrees. That's the related acute angle there. Remember, the related acute angle always goes up to the x-axis. Always to the x-axis, the related acute angle. Good to know, good to remember. Maybe that little hint, always to the x-axis, that would go on your cheat sheet too. 292. Done. There's your two solutions. Dandy. And that's the sort of, most of the new stuff for trig in that unit. A typical example, and I've got a whole bunch of scribbling on here, find the unknown side. This was review. This was review of grade 10 and grade 11 trig. So I'm not going to do it. We're going to actually see a trig example when we do vectors, when I review vectors, so I'm going to skip this. But I wanted to mention, sort of, as part of your cheat sheet, you might want to include some sort of problem-solving tree, a decision tree that leads you to the right formula. So the first question you might ask yourself, is it a right triangle? And if it is a right triangle, you're going to use SOHCAHTOA. If not, then you have to ask yourself another question. The question is there an angle-side pair? If there's an angle-side pair, then I use the sine law. If not, I'll use the cosine law. Notice in here, this one, I don't have an angle-side pair. The only angle I'm given is across from the unknown, so that's this case. In this case, it's a cos law where I want to find a side so I can see that formula. See, this decision tree, not only has all the formulas in there, but it'll help you reach the right formula if you're to put something like this on your formula chart, your formula sheet. In big red letters, beware the ambiguous case. Remember, the ambiguous case is sometimes if you're not careful and you're using the sine law, and you want an obtuse angle, your calculator will give you the related acute angle, right? They'll give you this related acute angle x, and you have to be aware enough to know that, if it's an obtuse angle, you could go 180 minus x. And sometimes we saw that if you're solving a triangle, you might have two possibilities. You have to do two full answers, which was no fun. It was a lot of work. In one question, give you two triangles. That's pretty tough. That's chapter 1, and I'm just going to boogie along here. Let's see how we're doing. 8 minutes. Let's see. I'm going to pause. I'm going to pause there because I think the next two units, see, this is Unit 1, Unit 2, and Unit 3 will be faster. So I'm going to pause there and do video 2 for these three.